Welcome to Utilizing Tech, the podcast about emerging technology from Gestalt IT. This season of Utilizing Tech focuses on Compute Express Link, or CXL, a new technology that promises to revolutionize enterprise computing. I'm your host, Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. Joining me today as co-host is Craig Rodgers.
Hi, Stephen. Good to see you again. Are you looking forward to talking about what Rambus are doing in the CXL space?
Excellent. Yes, indeed, I am. Many of us are very familiar with Rambus over the years. We've encountered the company, and I think a lot of us know that Rambus is responsible for some of the basic structure of how server memory is constructed these days. But I think some people might have some questions about sort of where that goes into CXL. But I mean, if you think about it, it makes a lot of sense that a company like Rambus would be in the CXL space, because in order to make this stuff real, there's going to need to be a lot of focus on the things that they have dealt with in the past: reliability, availability, serviceability, security, basically making this thing enterprise grade, right?
Absolutely. Given Rambus's historical exposure and experience with memory, and CXL first leveraging memory to enter the market, it makes absolute sense.
So let's then bring in our guest. Welcome, Mark Orthodoxou of VP of Strategic Marketing for Rambus. Welcome to the show. It's good to have you here.
Thanks, Stephen. Like you said, my name is Mark Orthodoxou, VP of Strategic Marketing for Datacenter Products here at Rambus. It's nice to talk to you guys today.
So, Mark, you heard what we had to say there. Let's start right off the bat with the sort of things that might hold back memory across CXL from really taking root in, basically big production environments.
Yeah, that's a great question, and one that I feel like, as an ecosystem, we don't necessarily talk enough about, because let's face it, for the first time ever, we're talking about taking system memory, sticking it off a serial interface, moving the memory controller off the CPU, and what are the implications of that? I mean, the biggest implication, of course, is that has to be reliable, and you said it in your intro there. I think the industry as a whole needs to kind of really focus in that area. If you think about the main CPU players, the Intels, the AMDs of the world that have for many, many years honed their memory controllers to work with system memory, mostly in the form of RDIMMs, that's a lot of man years of effort that have gone into ensuring that there's the right ECC technology, that there's no silent data corruption under most every use case, things of that nature. A lot of that work now has to be recreated by third parties, and that is not a easy task. Now, companies like Rambus, who have been in the memory business for a long time, are uniquely capable of doing that with some of the insights we've gained working with the memory suppliers. But that's one major element. The second piece of it is security, as you also mentioned in your intro. I mean, now we're moving memory a little further from the CPU. Security becomes a concern, and that has to be dealt with appropriately. And then I think more broadly, you talk about just the standards work that's required to ensure everybody's aligned on the foundational requirements for this type of memory attachment. A lot of work needs to be done there too, and Rambus is heavily involved in all those areas.
You mentioned there about standards. It's so important for something this big and this open. With so many members of the CXL Consortium, it's so important that this is all properly standardized, and for adoption to take place, it's going to have to be standardized. Companies won't simply throw it into a data center on the assumption that it's going to work. They're going to want to know how it works, how reliably it works, and how well they can maintain that, with serviceability moving forward.
The standards activities are quite involved now around CXL attachment of memory in particular, not strictly speaking memory, but a lot of focus is in that area. I mean, everybody knows the CXL Consortium, of course, which really is the foundational standards body that's essentially delivering the protocol. Rambus heavily active in that area. We actually, as of January of this year, we sit on the board of directors for the CXL Consortium, and actually are the only memory company that's building memory silicon that does so. Um, and that's one obviously major thrust. So foundationally, all the ecosystem players have to come together to make sure that the protocol itself is suitable for the application. But that's just one part of it. A lot of other standards bodies now are very involved by necessity because, as you pointed out, how do we use this stuff in production as things really ramp up over the next couple of years? And that has at least two other major components. One is what are the form factors and the standard, the most important requirements for the controllers that will implement this type of technology. JEDEC is very active in that, and Rambus has been working closely with JEDEC for many, many years. That standard, just like it's important in the RDIMM industry, is going to be important in the CXL industry. But then also, how do we manage this stuff at a software level, right? So you have bodies like OCP. Just back late last year, a new work group was formed formally, the Composability Memory Systems work group within OCP. And what is that group doing? Well, that group is essentially building an open source fabric manager for the purposes of managing all this tiered memory, which is going to be foundational for its use as we go forward. In the Linux community, there's kernel work to ensure open source kernels. So all this standards activity has to come together. The ecosystem has to agree on all these things for this to be deployed in any kind of meaningful volume in a ubiquitous way. And Rambus is heavily involved in all those groups, as are many of our customers and partners. So it's a very exciting time. It's really positive, I think, to see such broad activity across all these standards bodies. It speaks to the importance of the technology.
Yeah, I think that's what's been interesting to us here on the podcast is just the number of companies, the breadth of the companies that are involved, and all of the different uh, resources and ideas and technologies that are being brought together. And it's really, I think, important that companies like Rambus are there as well because of the long history, not just in terms of patents and technology, but even just understanding of this market. I mean, the Rambus is a company that has worked in the enterprise industry, enterprise server industry, and cloud servers. Nintendo 64, everything for so long, and yet having that kind of background and bringing that to the table is important because, for me as a storage guy, one of the things that kills me is, people kind of come in and sit down and they're kind of like, oh, how hard could storage be? We'll just store some data. It'll be fine. Well, it's the same thing with memory. I mean, people come in, if they don't know the memory business and you don't have the background in this and you don't understand what it takes to make memory reliable and to handle the issues that are going to happen and to predict what issues are going to happen, because we've seen this before and we'll see it again, you don't ask the right questions, and then you don't have something that's reliable. You don't have something that's highly available. And so it's good to have, that kind of background being brought to the table. So what is it that specifically that Rambus is bringing in terms of understanding of system memory to CXL?
Yeah, that's a great question, Stephen. Thank you. I mean, well, first of all, I can't claim any responsibility for what we were doing back with Nintendo many years ago. I'm about a year and a half new to Rambus, but I mean, the reason why I joined the team was because I feel that Rambus brings something very unique to this ecosystem. And I've been a big believer in the serialization of memory for many years now, all the way from back when we were talking about things like C6 and OpenCAPI or OMI and Gen Z. And CXL clearly has sort of taken the lead from an ecosystem adoption standpoint. And what Rambus brings is rather unique. First of all, as you pointed out, we have a great deal of historical contribution to the memory ecosystem through inventions and involvement with the memory suppliers by supplying chipsets that live in the RDIMMs that today ship ubiquitously in the data center. And we also have this rather unique pool of IP to draw from that we ourselves develop and sell to third parties in the form of CXL controller IP, PCIe controller IP, CERTAS, security blocks, and then a very strong SoC design team within Rambus that's able to take all these pieces and put them together to do something I think pretty special. And so when you look at the memory ecosystem and you think about companies that really kind of know the nuts and bolts of what it is to take things like DRAM and make them consumable um, on a mass scale, Rambus is rather unique. Now, when you think about the different ways that memory is going to be deployed with CXL, there's a whole bunch of different variations on that. And that's also important to consider in answering your question because there's a great deal of complexity, as I mentioned, in recreating the memory controller, taking it off the CPU and putting it external, and then attaching RDIMMs to that. You have to consider all the reliability things that any CPU would need to consider. But there's another type of use case as well, which is where DRAM is populated directly down on a board next to something like a CXL memory controller that necessitates an understanding of capabilities that are very analogous to what today you find in things like an RCD that live on an RDIMM. And very few companies have the understanding and the background to make that a productizable thing as well. There's a lot of nuance to it. So those are just a couple of things that come to mind. Well, I guess one other thing before in answering your question, um, you know, uh, Rambus has done a lot of acquisitions leading up to this point, and a lot of them were focused on enabling us in this area. One of the more recent ones is an acquisition we did of a company called Hardent. They're based in Montreal, Canada. And their expertise is in the areas of ECC, in the areas of compression, and it kind of hints to the types of things that we feel are necessary to have a very deep understanding of to make this thing successful. So those are a few things in answer to your question.
Yeah, and it's interesting too that you bring up sort of non-memory non-memory topics as well, because of course the differentiator for CXL memory is that it's going over PCI Express. It's probably going to be going over fabrics. There's probably going to be other types of I/O passing alongside it. There's a lot of questions that go beyond sort of what needed to be asked when you're talking about memory on a system bus, isn't there? So I think it's important to bring in, those kind of things. Bring in that kind of understanding. Maybe it's storage based or it's interconnect GPU based.
Yeah.
Those kind of understandings and meld them with how memory needs to work. Right.
Right. Well, I mean, exactly, 100%. I mean, when you take a step back and you look at the big picture here, I mean, what is CXL offering? Well, it's offering a new attach point for memory in one of its often talked about use cases. Why is that important? Well, that's important because today, I mean, there's lots of documentation or papers and talks about how important memory is from a cost standpoint, how the need for memory is growing, and what are the tools that are available in the absence of CXL to the system architect. It's really, you have HBM and you have various types of direct attached DDR. Well, and then you have storage, right? There was an attempt to bridge that gap a little bit with things like 3D XPoint. That's not really an option now. So what are the tools that we have in the toolbox? Well, CXL creates a whole bunch of those tools by creating these memory tiers. And as soon as you have these memory tiers, which to your point is very analogous to storage in the past, you have a whole bunch of different things you need to think about. You need to think about whether or not and what the use case is from a latency standpoint, for example, on whether or not you encrypt that memory. You need to think about things like um, storage techniques that are not entirely different from an FTL style layer you might see in flash SSDs today when you want to do some kind of post processing on a cooler tier of memory in order to use that memory more efficiently. There's a whole bunch of enterprise storage concepts that become very applicable to the memory space. Just pure data integrity through silicon and end to end in a system is an art that was really, in many ways, perfected in storage that is very applicable to the memory space. And I think carrying all those ideas forward in a deliberate manner, right? We can't bite off too much too quickly. Is going to be how this market actually is realized, how people actually start to find reliable ways to use these new types of memory tier to solve some of these problems. Given again today, their only option is throw more HBM at it or throw more direct attached DDR at it, which is fraught with all kinds of limitations.
There's been huge parallels between where we were with storage and where we're going with memory. And one of the first things we did, we had huge amounts of wasted storage in physical servers, that just weren't using it. So, and the solution was pooling it and virtualization. Now we're doing the same with memory. We're pooling the memory to let us mitigate that wasted resource, and it's an expensive resource to waste. But where we started off with storage with basic RAID, and then went into erasure coding. Storage has evolved over time, and SSDs and NVMe's. It'd be interesting to see where memory goes now. Once that pooling is going to be a foundation that other services, things that we haven't even thought of yet. Nobody was thinking of erasure coding on a physical server. It'd be very interesting to see where it goes.
Yeah, no, I fully agree. And there's a lot of conversations being had, both in closed door meetings and in standards discussions around exactly that universe of application space. And there are a lot of different thoughts on the right way to architect such a system. I mean, as you pointed out in storage, we saw that evolution happen in the form of different types of storage media with different types of interfaces, migrating to things like JBODs or JBOFs that attach to a number of servers. Will we see similar things for memory? I think we will. Will they live on the other end of a fabric? I think eventually they will. There's a lot of things to work through to get to that point. So I think that's an inevitable place that we will get to. I do think we need to crawl, walk, run a little bit as an industry, and again, I mean, to sort of the way we started this conversation, I mean, there are some foundational things to address in order to really convince the ecosystem that we have a reliable way to use this memory with the correct performance profile, and the right software infrastructure to manage it. And then that will continue to grow, and we will eventually see, reach that end of the rainbow where we're able to effectively utilize memory directly and remotely and with reliability, so that the architects have truly all the tools in their toolbox to architect servers and racks and data centers the way that they would like to, depending on the workloads that they have, which are themselves widely varied.
We're starting off with memory pooling, and we we believe that that's going to be quite rapidly and widely adopted. We don't know about, say, the future of CXL, features in 3, 4, 5, etc. And I'm getting these visions in my head of memes, design and user experience. You have companies like Rambus now that are building these, that are creating the tools, and then we're going to have companies who are actually building the CXL solutions. Where do you see those solutions going longer term? What, after memory pooling, what do you believe would be the next adoption down the CXL roadmap?
Well, there's a number of ways that um, we can look at a few different directions. So as you point out, memory pooling is broadly talked about. It seems to deliver a pretty obvious value proposition, which is use that expensive resource more efficiently, free up capital to purchase more memory, but use it smarter, purchase more data center infrastructure. Um, but I think we will see pooling of memory start to also eventually, over time, just more broadly become a foundational new component of what has often been talked about in recent years, which is the disaggregation of the rack, right? So I think what a lot of cloud service providers and large private cloud companies would love to get to is a truly um, sort of heterogeneous composable rack where they can plug and play things wherever they like. And that means also the attachment of GPUs and accelerators, the ability to do direct transfers from memory to memory, from cache to cache across those heterogeneous components. So that is, I think, one certain direction that the ecosystem is trying to move towards after, strictly speaking, pooling of memory. I think the pooling of memory is talked about most um, nearest term in terms of that sort of far memory, because it is such an expensive resource. There's never been a solution for this before. Whereas we do have some solutions right now for disaggregation of things like GPUs and accelerators over PCIe, and there's also some proprietary solutions out there, as most people know. Um, but putting that all together kind of is then the next step. You can't really do that effectively, strictly speaking, over, for example, PCIe. You need something like um, um, uh, CXL and the protocol enhancements that it brings to make that work. But the other thing that I'll say is, going back to direct attached memory, right now, we talk a lot about, well, you have this many, you know, um, DRAM channels on a CPU from an Intel or an AMD, or pick your favorite CPU company. And CXL, which runs over PCIe, which is a ubiquitous interface, there's increasing number of lanes per CPU to allow for it to be used to do interesting things. You could take that CXL memory and you could add more memory bandwidth or more memory capacity or introduce new types of memory over that additional interface. But I would suggest also that if you look far enough out, um, the CPUs themselves today, what are they growing to? More than 6,000 pins, something like that. Like, I've talked to customers that they can't conceivably go 2 DIMMs per channel on a socket in a CPU because they physically are running out of space in a server if it's a 2-socket server, for example. In fact, maybe even a 2-socket server becomes hard to build because these things get so large. So I would say that there's also a possibility down the road that the serial memory, as opposed to delivering a new memory tier, sort of is just the mechanism to attach memory to a CPU, whether it's hot, whether it's warm, whether it's cool, whether it's cold. And I would point to a company like IBM who's demonstrated, has pioneered sort of this thought experiment, which is, serializing memory on their Power Series. So is that a direction that we could also go? And that's going to require new standards work in terms of form factors of memory components, as well as perhaps the protocol itself. So there's a number of different directions that we could go beyond the direct memory attachment with CXL that we talk about quite a bit as an industry right now, and pooling, right? There's those two sort of different paths, which I think are very powerful and very interesting and speak to why we're all making these investments right now.
Yeah, and speaking of that, I think that we can all kind of understand where that Rambus is able to bring IP to the market in terms of helping, basically having. And I think you've already maybe announced some product in that area, or maybe we've heard about it. But where does the product picture go for you? Are you basically going to be enabling with IP, or are there going to be Rambus products?
Yeah, great question. As you know, Stephen, we haven't made any announcements yet in the area of specific CXL products. We do have, lots of information available about the IP that we make available to the ecosystem to build products of their own. All I can tell you right now is that we're doing some pretty interesting stuff in this area. And hopefully we'll be talking about it a little bit more openly soon. You do get a bit of a hint for the direction we're headed if you look at some of the publications that we've issued on our CXL initiative. But the rest of it, we'll have to wait for a future discussion before I can talk more about it.
Well, I can't wait to hear what that is. But in terms of IP, at least, it's great to know that you all are there to basically support these products that are coming to market with with the Rambus technology. And I guess for now, that is one of the approaches that a lot of companies are making to basically some of them are providing IP and some of them are providing product, and they're all meeting together in the CXL market. Another question that I would have relating to Rambus, though, is there's a whole thicket of intellectual property here. How does that work? I mean, if we're outsiders, we don't see how it goes. How does it work to bring technology from 30 different companies together into a standard?
Yeah, that's an interesting problem space, but one that we've navigated successfully in the past. And I'll go back to examples like storage, right? I mean, the situation was no different with SAS or SATA. It was no different with NVMe, even PCIe itself. And I think at a certain point, the opportunity for technology innovation and the need for product to enable it becomes so clear that you kind of have to sit at the table with your partners and your customers to ensure that we're all investing R&D dollars in a manner that we can deliver some ROI. And then the only way you can really achieve that is consensus at some level. And so, yes, is there an art in enabling standardization while leaving an opportunity for innovation? Absolutely. But it certainly is possible. It's been done before. And I think actually, to the credit of the end users of these products, and that's the cloud service providers, that's the server OEMs, um, they put a great deal of importance on participation and driving in a collaborative way that work, um, to the point where they will probably say that they don't want to partner with a company that is fighting or resisting that. Nobody wants to put something proprietary that is sort of defined in a dark room into a system that gets broadly deployed. And so it's really almost a mandatory part of the pre-sale cycle and of the industry enablement cycle. I mean, if you want to make product to address these things, you just need to collaborate in that way, and everybody sees it. It makes for some very interesting and heated discussions sometimes in standards bodies, but at the end of the day, it lands in a constructive place, and we'll navigate it just like we navigated in the past for some of those standards that I mentioned by example.
There's one thing you mentioned there that actually set off a wee light bulb moment in my head, and that was around the serialization of memory access. And I hadn't really thought of it that way. And again, I'm getting storage flashbacks, of parallel ATA and ultra two wide SCSI with 80 pins, and now it's down to a few pins on a SAS cable, and obviously the performance and latency and everything from where parallel was to now how it is in serial has improved. So it'd be very interesting to see if memory access took that trend.
I mean, at the end of the day, what is a CXL interface but a memory interface, at least in one incarnation, a memory interface that consumes 1/3 the pins of, for example, a DDR5 channel? How is that not a good thing for the compute ecosystem? And in the long run, if we can get the latency down to where it needs to be, the reliability down to where it needs to be, it seems to me that that could be quite ubiquitous. And I would also point out that when you couple it with standards like UCIe and other things, it also contributes to the disaggregation of the CPU itself at a chiplet level, because now you have new ways to plug and play different architectural components right at a package level, which again, it introduces all kinds of interesting possibilities.
Absolutely. And I think that, like you said, Mark, one of the things that I'm going to bring back in here to kind of look forward to where CXL goes, I think that one of the biggest problems that CXL is solving is what you mentioned earlier about basically the physical constraints that we're facing due to the system architecture choices that we made a decade ago. And so we've got too many pins, we've got too many lines, we've got too many memory channels, and we've been trying to overcome this. CXL allows us to overcome that in a way that not only means that the physical footprint of the motherboard can be redesigned and re-engineered, but in a way that allows us to basically blow up the whole concept of a server and maybe get to this kind of rack scale architecture. And I think that the coolest thing is that in the long term, that opens the door to basically more compute, more memory, more storage. It opens the door to building systems that are basically impractical given the constraints of current architecture. And that, I think, is really where this, everything changes, because there's all these dominoes that are going to fall down. As soon as we don't have, all these ranks and ranks of memory stacked across that server, we can move that stuff around. We can adjust cooling. We can adjust power. We can, basically adjust, how we place the CPUs. We can do all these things, and a lot of that is being held back by memory channels. And I think that this changes it.
Yeah, I mean, absolutely. And I mean, if anybody is wondering if the requirement for more memory is going to go away, I encourage them to type that question into Chat GPT and see what it tells you. The the point being that AI is not going to be slowing down anytime soon, and that's a big memory driver. I think on one of your other episodes, to highlight the point that you just made, you were talking to Dan Ernst at Microsoft, and he said something like, "Computer architecture isn't boring." So there you go. I fully agree with him, and I think that supports your point.
Absolutely not. And I think that that's really exciting to see where this is going. Well, this has been a wonderful conversation. I really appreciate having you on here. Also, I'm really glad to hear that you're a listener to Utilizing Tech. Where can people keep up the conversation with you? Where can they connect with you?
Yeah, thanks, Steve. And I certainly hope that I can connect with some of your viewers. The best opportunity coming up is I'll be delivering a keynote at MemCon 23 down in Mountain View, California, on March 29th. So feel free to grab me at the event. Please come to the session and talk to me afterwards. Also, you can reach me on LinkedIn. And for what Rambus is up to, please do visit rambus.com. Thanks again, Steve and Craig, for having me today. It was a lot of fun. Hope to do it again.
Great. Well, thanks for joining us. And Craig and I, will be a part of the Tech Field Day event that's happening. Actually, will be happened by the time this episode is published. So please check out YouTube/Tech Field Day for video recordings. And that features a presentation from this about CXL Consortium and a few of the other companies in the CXL space. So we look forward to having you join us there. Thank you for listening to Utilizing CXL, part of the Utilizing Tech podcast series. If you enjoyed this discussion, please do subscribe in your favorite podcast application or on YouTube. Also, please do give us a rating or review because, of course, that's always welcome. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to utilizingtech.com or find us on Twitter or Mastodon at Utilizing Tech. Thanks for listening.